Exercise 9.1, question number 1. A circus artist is climbing a 20 meters long rope which is tightly stretched and tied from the top of a vertical pole to the ground. Find the height of the pole if the angle made by the rope with the ground level is 30 degrees. So this is the figure they are given. So AC given 20 meters and angle is 30 degrees, and we are going to find out here AB here. So here sin 30, when you are going to see sin 30, so that will be AB by AC here. So sin 30 we know, which is 1 by 2 here, and AB we are going to find out AC, which is given 20 meters here. So AB is equal to 20 by 2, so that will be 10 meters here. So this is the height of the pole. Question number 2. A tree breaks down to storm and the broken part bends so that the top of the tree touches the ground, making an angle 30 degrees with it. The distance between the foot of the tree to the point where the point top touches the ground is 8 meters. Find the height of the tree here. So here we are going to see a tree here. So here, from here it bends here and touch to the ground here. So here it touches to the ground. So the distance between the point to this here, it is given 8 meters. 8 meters. So the angle formed here, which will be 30 degrees here. This is 30 degrees here. So here we are going to find out the height of this tree here. So let it be here A point, here B point, here C point, and here this D point. So the given data is BC is given, angle 30 degrees is given. So here first we are going to find out DC here. Then we are going to see DB. Then we are going to add DB plus DC here. So first we are going to see the DB here, then DC, then adding this D and DB and DC, we get AB here. That means height of the tree here. So here DB, how you are going to find? Tan 30 we are going to take here. So tan 30, when you are going to take, it will be DB by BC here. DB by BC here. So tan 30, which is 1 by root 3 here, and DB we are going to find out. So BC, which is given 8 meters here. So DB equal to 8 by root 3 here. So this is DB here. So now when you are going to see DC, so DC we have to find out. So DC, how we are going to find out? Cos 30 we are going to take here. So cos 30 here, when you take, it will be BC by DC here. So cos 30, which is root 3 by 2 here, and BC, which is given 8, DC we are going to find out here. So DC is equal to 8 into 2 by root 3 here. So that will be 16 by root 3 here. So this is a DC here. So we can also find DC by taking sin 30 here. Sin 30 also we can find out. So let's see with the sin 30. So sin 30 when you are going to take, which will be dB by dc here. So sin 30 we know, which is 1 by 2 here, and dB which is 8 by root 3 and by dc here. So dc is equal to 2 into 8 root 3. So that is 16 root here 8 by 3, 8 by root 3, and here we get 16 by root 3 here. So DC we got 16 by root 3 and dB 8 by root 3. So here height of the tree, height of the tree is equal to dB plus dc here. So dB how much, which we got 8 by root 3, and dc we got 16 by root 3 here. So taking LCM here, so root 3 here 8 plus 16 here. So that will be equal to 24 by root 3 here. So multiplying root 3 here in order to take this root, so we get 24 root 3 by root 3 into root 3, which is 3. So here 3, here 8. So 8 root 3, 8 root 3 is the height of the tree here. Third question. A contractor plans to install 2 slides for the children to play in a park. For the children below age 5 years, she prefers to have a slide whose top is at the height of 1.5 meters and is inclined at an angle of 30 degrees to the ground. Whereas for elder children, she wants to have a steep slide at a height of 3 meters and inclined to an angle of 60 degrees to the ground. What should be the length of the slide in each case here? So here 2 slides we are going to see here, whose height is 1.5 and 3 here. So these are the 2 slides. So let it be A here, here B, here C. So one figure which is having height 1.5 meters and angle of 30 degrees here. Next, when you are going to say ABC here and height 3 meters and angle of 60 degrees here. So now we are going to find out AC in both the figures here. So AC sin 30 when you take, we get AB by AC, then AC we can find out. Here sin 60 when you take AB by AC, we get AC here. So in this way we can calculate the AC here. So figure 1 when you are going to take, this is figure 1, this is figure 2 here. So in one case we are going to take sin 30 here, which is AB by AC here. So sin 30 is how much? 1 by 2 here. AB how much? 1.5 by AC here. So AC equal to 1.5 into 2 here. So that will be 3 meters. So AC equal to 3 meter. That means length of the slide here. So in second figure, when you are going to take, we are going to find AC here. That means sine 60 we are going to take here, sine 60, which will be AB by AC here. So sine 60, which is root 3 by 2 here, and AB, which is given 3, and AC we are going to find out. So AC equal to 3 into 2 by root 3 here. So here root 3 and here root 3. So we get AC is 2 root 3 here. So the length of the slide is 2 root 3 here. Question number 4. The angle of elevation of the top of a tower from a point on the ground which is 30 meters away from the foot of the tower is 30 degrees. Find the height of the tower here. So here when you are going to see the height of the tower in this way, and it is inclined and with 30 meters away here. So let it be A, here B, here C here. So the BC length which will be 30 meters here, and angle of inclination which is 30 degrees here. So we are going to find out the height of the tower, which is AB we are going to find out. So here we are going to take tan 30 degrees here, which is AB by BC here. So tan 30, which is 1 by root 3, and AB by BC, which is given 30 meters here. So AB equal to 30 by root 3 here. So here we are going to multiply with root 3 and root 3 in order to remove square root from the denominator. So we get here 30 root 3 by root 3 into root 3, 3 here. So here 3, 10 times. So then we get 10 root 3 meters here. So the height of AB, which is 10 root 3 meters here. Question number 5. A kite is flying at a height of 60 meters above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degrees. Find the length of the string, assuming that there is no slack in the string. So here given let it be A here, here B here, C here. So the given data, height of the kite from the ground which is given 60 meters here, and angle which is formed here, it is 60 degrees, and we are going to find out AC here. So this we are going to find out the length of the string here. So here we are going to take first sine 60 we are going to take, which is AB by AC here. So sine 60, which is root 3 by 2, AB which is given 60 meters, and AC we are going to find out here. So AC equal to 60 into 2 by root 3 here. So we are going to multiply root 3 numerator and denominator in order to remove the square root here. So into root 3 by root 3 here. So here we get 60 into 2 into root 3 by 3 here. So here 3 1, here 3 20. So 20 into 2, we get 40 here, root 3 meters. So this is the length of the string here. Question number 6. A 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degrees to 60 degrees as he walks towards the building. Find the distance he walked towards the building here. So here, so this is the building. So this is the height of the person, the boy, which is 1.5 meter here. So let it be here A here. So this will be, let it be B here, here C, and here in elevation we are going to take, let it be D here. So height of the building here, total 30 meters here, total 30 meters. That means AE is 30 meters. So the height of the boy is 1.5 meters and the angle which he made, which is 30 degrees, and he walked towards the building, the second angle is 60 degrees here. So here what they asked in the question is find the distance he walked toward the building. So that means from here to here he walked. So we are going to find out CD here. So how we are going to find out CD here? In the sense, we are going to take first AB here. AB how much? Which is AE minus this height. So let it be F. FC. So or B. So AB, AE minus B. When you are going to take, that means 30 minus 1.5 meters. That will be 28.5 meters here. So this is the AB height. So now we are going to find out first BC here. Then we are going to take BD here. So the distance of BC minus distance of BD, we get CD here. So how we find out first BC here? In the sense, we are going to take angle tan here. So tan 30 when you are going to take, so we get AB by AC here. So we get AB by BC here. AB by BC here. So we get tan 30, which is 1 by root 3, that equal to AB 28.5 by BC here. So BC equal to, which is 28.5 root 3 here. So this is BC. Now we are going to find out BD here. So in triangle ADB, when you are going to take, we are going to take tan 60 here. So tan 60, so that will be AB by BD here. AB by BD here. So tan 60, which is root 3, that equal to AB by AB already is given, which is 28.5, and BD we are going to find out here. So that means BD equal to 28.5 by root 3. So we are going to take the square root from the denominator. So we are going to multiply with root 3 and root 3 here. So that will be 28.5 into root 3 by 3 here. So here 3, here 3. So at 9.5 it divides. So we get 9.5 root 3 here. So we got BC and BD. Now we are going to find out CD here. So CD means what? So CD means which is BC minus BD here. So BC how much? We got 28.5 root 3 minus here BD which is 9.5 root 3 here. So taking root 3 common here, we get 28.5 minus 9 here. So 28.5 minus 9 which gives here 19 root 3 here. So the CD distance is 19 root 3. That means the distance he walked from the building is 19 root 3 meters here. Question number 7. From a point on the ground, the angles of elevation of the bottom and top of the transmission tower fixed at the top of 20 meters high building are 45 degrees and 60 degrees respectively. Find the height of the tower here. So this is the figure which is given. The height of the building is 20 meters, that is BD, and the height of the tower we are going to find out here. So the elevation from bottom here 45 degrees and from top is 60 degrees. So here we are going to find out AD here. So first we are going to find out BC here from triangle DBC here. We are going to find out BC. So after that we are going to find out here AB here. So AB and AB we got. So after that BD is given. So the difference between AB and BD, we get the height of the tower here. So first in triangle BCD when you are going to take, so the triangle BCD when you are going to take, the tan 45 degrees we are going to take, which is DB by BC here. So the angle formed is 45 degrees and DB by DC. So tan 45 which is 1 here and DB which is given 20 and BC we are going to find out. So BC is equal to 20 into 1, that means 20 meters here. So we got BC here. So now we are going to find out AB here. So in triangle when you are going to take, so triangle ABC when you are going to take tan 60, so that equal to AB by BC here. So a tan 60 which is root 3 here. AB we are going to find out and BC we got which is 20 meters. So AB equal to 20 into root 3 here. So now we got AB and BC. So we are going to find out AD here. So AD equal to AB minus BD here. So AB how much? 20 root 3 minus BD 20 here. So taking 20 common here, we get 20 root 3 minus 1 meters here. So this is the height of the tower which is AD here. Question number 8. A statue 1.6 meters tall stands on the top of the pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60 degrees and from the same point, the angle of elevation of the top of the pedestal is 45 degrees. Find the height of the pedestal. So here, so data given. So this is the So 2 points here. So this is A, D, here B, and here C here. So here given which is height of the statue, which is 1.6 meters on the pedestal. So this will be 1.6 meters here, and this height we are going to find out. So let it be x here. So angle of elevation, when you are going to see from top it is 60 and from bottom it is 45. So this angle it will be 45 degrees and this angle will be 60 degrees here. So now first we are going to find out in triangle DBC, we are going to find out BC here. Then after that in triangle ABC, we are going to find out AB here. So after that we are going to take the x value and we get the height of the pedestal here. So in triangle DBC, when you are going to see tan angle is 45 degrees, so tan 45 we are going to take, which will be BD by BC here. So tan 45 we know, which is 1 here, and BD, which is x, we are going to find out, and BC we are going to find out. So BC equal to x here. So now we are going to take triangle ABC here. So triangle ABC, when you are going to take, here angle is 60 degrees. So we are going to take tan 60 degrees here. So tan 60 AB by BC here. So AB by BC here. So tan 60, which is root 3, that equal to AB how much? 1.6 plus x here. So 1.6 plus x here, and BC we got, which is x here. BC we are going to find out here. So now BC equal to 1.6 plus x by root 3 here. So BC also, here we got x here, so we can write here x here. So directly we can write here x. So no need to. So x value we are going to take here now. So x value, when you are going to take, we get the height of the pedestal here. So here root 3 equal to 1.6 plus x by x here. So here root 3x equal to 1.6 plus x here, and here root 3x minus x equal to 1.6 here. So x we are going to take common here, we get root 3 minus 1 equal to 1.6 here. So x equal to 1.6 by root 3 minus 1 here. So this is the height of the pedestal. So if you want to simplify further, we can go multiplying and dividing by root 3 plus 1 by root 3 plus 1 here. So we get a minus b into a plus b, that means a square minus b square. So 1.6 into root 3 plus 1. So here a square means root 3 square will be 3 here, and here 1 here. We get 1.6 root 3 plus 1 by 2. So here 2 to 0.8. So that means 0.8 root 3 plus 1 meters is the height of the pedestal here. Question number 9. The angle of elevation of the top of a building from the foot of the tower is 30 degrees and the angle of elevation of the top of the tower from the foot of the building is 60 degrees. Find the tower. If the tower is 50 meters high, find the height of the building. So here data given. So one is a tower, another is a building here. So this is a tower and this is a building here. So height of the tower which is given, which is 50 meters here. So angle of elevation from here to top and angle of elevation from building to here ground level. So here 30 degrees and here 60 degrees here. So let it be A here, here B, here C and D here. So we are going to find out the height of the building here. So first in triangle ABC we are going to find out BC here, BC. So after that with the help of BC in triangle BDC we are going to find out height of the building here. So first we are going to take triangle ABC. So triangle ABC. So we take angle 60 which is tan 60 that equal to AB by BC here. So tan 60 which is root 3 and AB we given which is 50 and BC we are going to find out here. So BC equal to 50 by root 3 here. So in order to take the square root we are going to multiply and divide by root 3 here. So that gives 50 root 3, 50 root 3 by 3 here. So now we got BC here. So in triangle DBC, BDC we are going to take. So triangle BDC when you take angle is 30 degrees. So we take tan 30 here which is DC by BC here. So tan 30 which is 1 by root 3 and DC we are going to find out by BC which is 50 root 3 by 3 here. So 50 root 3 by 3 here. So DC equal to we get so here from here, so 1 by root 3 equal to DC by 1 into 3 by 50 into root 3 here. So DC equal to 50 root 3 by 3 root 3 here. So here root 3 cancel, we get 50 by 3 here. So 50 by 3 DC is the height of the building. So 50 by 3 can also be written as 16 2 by 3 meters here. So the height of the building is 16 2 by 3 meters. Question number 10. Two poles of equal heights are standing opposite each other on either side of the road which is 80 meters wide. From a point between them on the road, the angles of elevation of the top of the poles are 60 degrees and 30 degrees respectively. Find the height of the poles and the distances of the point from the poles here. So here two poles we are going to see, and the distance between these poles is given, which is 80 meters. So one point, say this point, the angle from this pole to here and angle from this pole to here. So let it be here 30 degrees and this pole 60 degrees here. So here we are going to find out the height of the poles here. So that means this is H and this is H here. So let it be A here, here B here, here C here, and here D here, and this point let it be E. So here the BC is given, which is 80 meters. So let this point be X. The distance of BE is X. Then the distance of EC will be 80 minus X here. So here we are going to take a triangle first, ABE. We are going to find out X here, and from DCE we are going to find out X here. So here we get X. After that we are going to find out the height of the poles here. So first we are going to take triangle ABE. When you are going to take which is 30 degrees, so tan 30 we are going to take, which is AB by AE here. So tan 30 we know, which is 1 by root 3 here, and AB let it be H here and AE X here. So H is equal to X by root 3 here. So let it be equation 1 here. Next we are going to take another triangle, which is triangle DCE here, and angle is 60. So we are going to take tan 60 here. So tan 60 when you take, so DC by EC here. So tan 60 we know, which is root 3 here, and DC the same height, so H, and EC which is 80 minus X here. So H equal to root 3 into 80 minus X here. So let it be equation 2 here. So we get two equations which are equal. That means the height of both poles are equal. That means equation 1 is equal to equation 2. So X by root 3 equal to root 3 into 80 minus X here. So here X equal to root 3 into root 3, we get 3 here, 80 minus X here. So X is equal to here 240 minus 3X here, and 3X plus X, 3X plus X equal to 240 here. So 4X equal to 240 and X equal to 240 by 4. So X equal to 60 here. So we got X here. So in the question they asked height of the pole, so not X. So when you are going to see this angle, we get X 60, and here this when you are going to take, we get the distance 80 minus 60, which is 20 here. So let take X when you are going to substitute in equation 1. So H equal to 60 by root 3. So root 3 when you are going to multiply root 3 by root 3, we get 60 root 3 by 3. So here 20, so we get 20 root 3. So height of the pole is 20 root 3. So if you are going to substitute in the second equation, so h equal to here root 3 into 80 minus 60, then here root 3 into 20 here, to 80 minus 60, 20. So in the both cases the height will be same here. So 20 root 3 is the meters, is the height of the pole here. Question number 11. A TV tower stands vertically on a bank of a canal. From a point on the other bank directly opposite the tower, the angle of elevation of the top of the tower is 60 degrees. From another point 20 meters away from this point on the line joining this point to the foot of the tower, the angle of elevation of the top of the tower is 30 degrees. Find the height of the tower and width of the canal here. So here in the diagram we are going to see, we are going to find out here the height of the tower, which is AB, and also we are going to see the width of the canal here. So here first we are going to take triangle ABD here, ABD, and we are going to find H value here, and in triangle ABC also we are going to find out H here. So in both equations when you join, we are going to get BC here, and from there we are going to find out the height of the tower here. So let BC be X here, and here AB be H here. So in triangle ABD, when you are going to take tan 30 equal to AB by BD here. So which is H by here 20 plus X here. So H equal to, so tan 30, which is 1 by root 3, that equal to H by 20 plus X here. So then H equal to 20 plus X by root 3 here. So which is equation 1 here. So now we are going to see triangle ABC here. So from ABC, tan 60 equal to AB by BD here, which is H by X here. So tan 60 we know, which is root 3, that equal to H by X here, and H equal to root 3 X here. So let it be equation 2 here. So from equation 1 and 2, when you are going to say 1 and 2, 20 plus X by root 3 equal to root 3 X here. So when you are going to cross multiply, 20 plus X equal to root 3 here, 3X here. So here 3x minus x, that means 2x equal to 20, and x equal to 20 by 2, and x equal to 10 meters here. So we got x. So when you are going to input in equation 1 here, equation 2 here, h equal to root 3 x, that means root 3 into 10, so that will be 10 root 3 meters here. So the height is 10 root 3 meters here. Question number 12. From the top of a 7 meters high building, the angle of elevation of the top of a cable tower is 60 degrees. Angle of depression of its foot is 45 degrees. Determine the height of the tower here. So here we are going to see a tower here, and here one building. So there elevation, and here depression. So let it be A here, here B, here C, here D here. So height of building given, which is 7 meters. Angle of elevation, which is given 60. Angle of depression, which is 45 degrees. And we are going to find out AB height here. AB height we are going to find out. First we are going to find out in triangle BDC. We are going to find out BD here. After that BD is equal to here CE. Then in triangle ACE we are going to find out AE here. So after finding AE plus EB is equal to AB. That means the height of the tower here. So first in triangle BDC, when you are going to take here, so this angle is 45 degrees, means this angle also 45 degrees here. So here tan 45 degrees is equal to CD by DB here. Tan 45 we know, which is 1 here, and CD is given 7, and DB we are going to find out here. So DB is equal to 1 into 7, which is 7 here. Next we are going to take triangle. So here BD, so DB is equal to EC here. So both are equal. So here also 7 meters, here also 7 meters here. So now we are going to take a triangle ACE here. ACE here we are going to take. So tan 60 we are taking. So tan 60, which is AE by CE here. So tan 60, which is root 3 here. AE we are going to find out, and CE we found out, which is 7 here. So AE equal to 7 root 3 here. So now we got AE, which is 7 root 3, and here CD is equal to BE. CD is equal to BE. So that equal to 7, which is given here. So now AE equal to, so AB equal to AE plus EB here. So AE how much we got, which is 7 root 3 plus EB is 7. So we are going to take 7 common here, which is root 3 plus 1. So 7 root 3 plus 1 meters is the height of the tower here. Question number 13. As observed from the top of a 75 meters high lighthouse from the sea level, the angles of depression of two ships are 30 and 45 degrees. If one ship is exactly the other on the same side of the lighthouse, find the distance between the two ships. So here a lighthouse is there. So here two ships when you are going to see. So one angle of depression which is 30 and other is 45. So here this is 45, one is 30, another is 45. So let it be A here, here B, here C, here D here. So here we are going to find out the distance between two ships. That means CD we are going to find out here. So here 30 degrees means here also it is 30 degrees and here 45 degrees means here also it is 45 degrees. So now we are going to find out in triangle ABC. We are going to find out BC here. After that in triangle ABD we are going to find out DC here. So in triangle ABC when you are going to take, so tan 45 degrees that equal to AB by BC here. So tan 45 we know 1 and AB which is given 75 degrees and BC we are going to find out. So BC is equal to 75 here. Next in triangle ABD, in triangle ABD here. So we take tan 30 here. So which is AB by BD here. So tan 30 we know which is 1 by root 3. AB we found out which is AB we are going to find out which is given 75. So here 75 meters, 75. So BD which is BC plus CD. So that means 75 plus CD here. So by cross multiplication 75 plus CD equal to 75 root 3 here. So CD equal to 75 root 3 minus 75 here. So taking 75 common here, we get root 3 minus 1 meters here. So this is the distance between two ships, 75 root 3 minus 1 meters. Question number 14. A 1.2 meter tall girl spots a balloon moving with a wind in a horizontal line at a height of 82.2 meters from the ground. The angle of elevation of the balloon from the heights of the girl at an instant is 60 degrees. From some time, the angle of elevation reduces to 30 degrees. Find the distance traveled by the balloon during the interval. So here a girl height which is given, which is 1.2 meters and total height which is 82.2 from the ground. So here we are going to find out. So let it be A here. So here height means here B. Let the point be C here. So this point be D here. Here E and here F. Here suppose G here. So now we are going to find out first height of GF here. That means 82.2 minus height of the girl here. Then we are going to find out in triangle ACD. We are going to find out this AC part here, this part, and next we are going to take triangle AGF and we are going to find out AF here. So after that AF minus AC we get CF. That means the distance between traveled by the balloon from D to G here. So first we take the distance of the height of the balloon here. So here from eyes of the girl, that means 88.2 minus 1.2 meters, that will be 87 meters here. So here we got height, that is GF, which is 87 here. So the same height will be for DC also. So this is also 87 here. So now we take a triangle ACD here. So triangle ACD, when you are going to take, so tan 60 we take here. So that will be CD by AC here. So tan 60 we know root 3 and CD, which is 87 by AC. So AC equal to 87 by root 3. So here multiplying and dividing by root 3, so that will be 87 by root 3 into root 3 by root 3. So that will be 87 root 3 by 3. So that will be here 29 root 3 here. So AC equal to 29 root 3. So now we are going to take another triangle, which is AGF. So AGF we are going to take. So here we are going to take tan 30 here. So that will be GF by AF here. So GF by AF. So tan 30 means we know 1 by root 3, that equal to GF, which we know 87 by AF here. So AF equal to 87 root 3 here. So now we want CB here, CE here, the distance between the balloons. So CE, when you are going to see, that will be AF minus AC here. So AF we got, which is 87 root 3 minus AC, which is 29 root 3. So taking root 3 common here, we get 89 minus 87 minus 29. So that will be 58 root 3 here. So 58 root 3 is the distance traveled by the balloon during the interval. Question number 15. A straight highway leads to the foot of the tower. A man standing at the point at the top of the tower observes a car at an angle of depression of 30 degrees, which is approaching the foot of the tower with a uniform speed. 6 seconds later, the angle of depression of the car is found to be 60 degrees. Find the time taken by the car to reach the foot of the tower from this point. So here, so this is the tower. So let it be A here, B here, C here. So first the angle of depression, which is 30 here 30. Next, at after 6 seconds, the angle is depression is 60 degrees. So that means this angle is 30 degrees and this angle is 60 degrees. let it be D here. So the time taken here is 6 seconds here. Now we are going to find out the car to reach the foot of the tower from this point. So first in triangle ABD, when you are going to take, so tan 60 is equal to AB by BD here. So let your AB be H here, here X here. So that will be tan 60, which is root 3, and here H by X here. So H equal to root 3 X. So let it be equation 1 here. Next, in triangle ABC, when you are going to take 30 degrees, that is tan 30, which is AB by CD here. So tan 30 we know root 1 by root 3, that equal to AB, which is H. H we got in equation 1, that is root 3 X by CD, which is 6. Here CB here 6 plus X here. So now cross multiplication, 6 plus X equal to root 3, we get 3X here. So sending to here 3X minus X, which will come 2X equal to 6 here, and X is equal to 6 by 2. So that will be 3 here. So 3 seconds is the answer.